fill in the blanks over there for our Rossby number. But it's kind of hard because it's such a diffuse front. So there's an easier way to see velocity. Everybody got a decent look at this? I'm about to drop some more stuff in here. Purdy. Now we should. I really should hook this. This thing can all be hooked up to a video recorder. We should really make our own videos. According to Gunnar, all the ones that are on YouTube are lame, and ours are apparently a lot better. Wait till you see that.
I got a picture of the screen.
Now, what I'm going to do here is I'm going to drop some things in here.
Yes, perfect.
I don't want them to stick to the tank, so the trick is getting them where they don't stick to it. Because, see, the one got sucked over to the tank. What's causing that? It's something we studied. What would cause a little paper thing to go?
Surface tension.
Surface tension, yeah. So I'm trying to keep it far enough away from the... It's amazing. This is the cool thing about surface tension. Like, how does the dot know that tank is over there? Well, surface tension. Okay. So, now, if you look at the tank, you can say, oh, well, the dots are rotating along with the tank. But look at the screen. What's the screen telling us? Are they rotating the same speed as the tank? No, because they're actually... You have to use the screen in order to really accurately see how fast they're moving. Right? And they are moving. Now, which way are they going? They are going the anti-clockwise direction, right? Counterclockwise. Which way is the water on the bottom going? Clockwise.
Will they begin to move once they're in solid body rotation with the water?
The water is...
You know how you said that you had to wait for the water to move in solid body rotation?
Water is no longer in solid body rotation, though, because I've now put an energy gradient in here, so I've induced a rotational, a flow on here. So this water is no longer... This water is now a big old spiral. It's like a twisted donut kind of...
Right.
Because what's happening is, imagine, start with one of those plumes and follow it. What the water is doing is going that way, it's going up, and it's coming back, and it's going the opposite direction when it comes back, and then drops. Okay? And so what we're seeing, there's two different currents. There's actually a current flowing on the bottom. That is, if I could put a little miniature submarine down the bottom, it would be going clockwise around, and then these little floaties on the top are going counterclockwise around the top. You should get a mini submarine.
Our tuition dollars matter.
A little radio-controlled one so I can have it die. Anyway, so there's really now it's no longer anything like this. I can't even begin to make it out of paper what it looks like now. It's this big spiral. The water is going down, over, back up, so it's coming back towards me, and then drops and goes away from me. It comes up. And that's why the dots... And in the end, all the water is going in a... So what you see at one particular altitude is, if we were at ground level, so this is ground level down here, which way is the wind blowing? Well, let's look at our compass. Which way is the wind blowing on ground level, according to that? Well, it says right there, north, south, east, west. It's blowing... It's a northeast wind, right?
Yeah.
This is really what you're looking at. There's the wind there.
I mean, depending on where you are from the center,
here
would be more of an east.
Yeah, exactly. It shifts a little bit in this system. Okay, so we're getting, as predicted, we're getting generally easterly trade winds. So these are the trade winds. And, of course, it's a little more exaggerated out of the north than the actual trade winds because of the size of the tank. Okay. But at the surface, which is up at 60,000 feet in the air, which way is the wind blowing? It's blowing, which way are the dots rotating? They're going out of the west.
Counterclockwise.
Yeah, they're going counterclockwise. So up here is a west wind. Okay, so up in those upper altitudes, there's a west wind, east wind. So you actually have two different winds. Okay. And by the way, that also means there's quite a bit of shear in here, meaning if the bottom of this water is going that way, and the top is going this way, that is, it's tending to shear the water. So those of you who have had or taken fluids lab have learned about Newton's law of viscosity and shear stress in water. There obviously is that going on here, and that tends to mix things for everybody. You don't even have to know fluids to know that. If I tend to pull the water this way at the top and that way at the bottom, what does that tend to do? It tends to induce mixing in the atmosphere. Okay. So this is such a slow-moving system. The water is so viscous that we're not actually going to get turbulence. But in a real atmosphere, if the wind is blowing this way at the top and that way at the bottom, it tends to kick up the atmosphere, and that mixes the atmosphere pretty well.
So the tank is rotating counterclockwise.
Yeah, the tank is rotating counterclockwise.
The dots are rotating counterclockwise.
Also, but they're
rotating faster.
They're faster than the tank, though, and that's what the camera tells us.
That's why I asked about the solid body rotation thing.
Right. Yeah. See, it's no longer in solid. Now, the one last cool thing we could do, actually, with somebody, so I'll fight my way back by the sink. Would you grab, without getting all of yourself, those bottles of dye and the pipetter gadget? Just watch the pipetter. That's how you'll get the dye on yourself. And it's bad stuff. The red dye is.
In the back see,
Yeah.
you can kind of see some straining necks, and feel free to holler for folks in the front, maybe that.
Yeah.
Elbows are
Yeah, it's like anything else. It's more interesting to close up to it. Getting close to the shoulder. Okay. Now we're going to do one more thing, which is since we can't really. I told you I can't make the spiral out of paper, but I can make us visualize the spiral if I add a little bit of dye around here. This is where it gets really trippy. Seriously. Okay. Again, it's not what happens right away, but pay attention to it as it develops. Now, this is where everybody is going to want to get up close and watch what's happening. We saw that in the little tank, the dye just sort of sank, right? Here, it's not just sinking. What's it doing? It's sinking and doing what?
Rotating.
Yeah, and it's going into a spiral, isn't it? It's spiraling. But also, which way is the dye at the top going? Clockwise or counterclockwise?
Counterclockwise.
It's going counterclockwise because, of course, at the very top, it's going the same speed as the dots, right? But down below, which way is it going? It's going. It's got to be going the same. Once it hits the bottom, it's going to go the same as the permanganate. So it's going to go the same as the purple. In fact, you can see that now. In some places, it's starting to track out with the permanganate. And those little dot tracers, as they're dropping, they're spiraling to the bottom. But the top ones are going the other way. So you got this double spiral thing going on. And like I say, definitely get up close to this one because this is like where it really looks cool in profile. So everybody take a turn. And also feel free to, again, it looks really cool from the top. Just stick your head in there. Just don't get hit by the rotating camera. Hang into the cart. Now we're going to start over. No, I just want to start over.
Oh, this camera was just
Okay, one last thing we could do is we wanted to estimate velocity. So the easiest ones to estimate would be the dots moving at the top. Let's find some dots that are not too close to the side so that they're stuck. How fast did they?
Special tool.
Yeah, that's my build. I marked in centimeters on there. I'm not sure that that's helpful to us because you really kind of have to see it. What would you estimate the velocity there is? You got the centimeter scale sort of to go on. 1 centimeter per second, 2 centimeters per second, 10 centimeters per second. What do you think?
1.
Yeah, you kind of visualize how far 1 centimeter would be on there.
It'd be useful to have centimeters.
That's what we'll do. Okay, we'll do that for the next one. We'll mark on the top. I was thinking on the side would be helpful, but yeah.
We'll do that next year, so it'll benefit you.
Every time. See, I thought of putting little things on the side this year. Next year. Wait till next year. Okay, anyway. Yeah, I would say. I mean, or again, you can just kind of come over and look in. I would say the ones that are too close are not accurate because they're being held by surface tension. One of the ones that will fly out. Order of magnitude about 1 centimeter per second, maybe a little slower. Okay. So as I put on the board now, we can fill in the blanks over there. I said, what's our Rossby number? So it's V is going to be what? 1 centimeter per second,